Question number 15. Ravi and Sika drive around a circular field. Ravi takes 16 minutes to complete one round while Sika complete the round in 20 minutes. If both start from the same point at the same time and go in the same direction, after how much time will they meet at the starting point? So there is one circular field. In the circular field, to complete that circular field, Ravi needs 16 minutes and Sika need 20 minutes. So and they will start at the same point in the same direction. So after how many minutes they will be at the same position again? So here we need the LCM. This is question number example 15. So what is the number? This is a circular path. This is a circular field. Ravi needs 16 minutes and Sika need 20 minutes. They will means complete this circle in same direction. So after how many minutes they will be at the same position? So we have to do the LCM. So LCM of 16 and 20. So this is 16. It's divisible by 2, 8, 2, 4, 2, 2. Another is 20. 2, 5. So 16 is written as 2 into 2 into 2. How many 2? 1, 2, 3, 4. 1, 2, 3, 4. 2 to the 4, 4. 20 is written as 22 into 2 into 5. That is 2 square into 5. This is square. We need the LCM. LCM of 16 and 20. So we have the 2 here. Here also we have the 2. So which one? In the LCM we are going to take the highest power. So 2 to the power 4 is the highest. Now another prime number we have 5. So 2 to the power 4 is 2 multiply the 2 4 times. So it gives us 2 into 2 into 2 into 2 into 1, 2, 3, 4, 5. 5 to the 10. Now 2 to the 4, 4 to the 8. So it is 80. So they will need 80 minutes. Hence, whenever it's 80 minutes, or you can convert into hours. In how many hours? It's in 60 minutes we have 1 hour. So it will be 1 hour 20 minutes. 80 minutes. That's it. If divide by 60, then we will get 1 hour 60, 70 to 20 minutes. So after 1 hour 20 minutes, they will be at the same position, in the same place. Hence, both will meet at the starting point after 1 hour 20 minutes. After 1 hour 20 minutes. Now question number 16. What does the question number 16 says? In a school there are 2 sections, namely A and B of the class 10. Okay. In the one section there are 30 students in section A. In section A there is 30 students. In the section B there are 28 students. Find the minimum number of books required for their library. So there is means preparing to make the library for them. So we have to find the minimum number of books, means how many books we will put in there so that everyone will get the book, so that they can be distributed equally among students of each section A or B section. Means what will be the minimum number of books in that library, so that everyone will get equally the same number of books in the library, equal number of books. So there are two sections, section A, section B. In the section A 30 students, section B 28 students. So there is to make the library, in the library how many, what should be the minimum number of books in the library, so that everyone will get the equally book from the section A as well as from the section B. So now we have to do the LCM of these two numbers. This is 16. So what is the number we have? 30. Section B we have 28. So prime factorization of 30, divisible by 5, 6, 3, 2. Divisible by 2, 1, 4. Divisible to 7. So 30 is equal to 2 into 3 into 5, or that is 28 is equal to 2 into 2 into 7, that is 2 square into 7. Now LCM of 30 into 28. What is the number? We have what the prime number? We have 2. Here we have 2. Here we have 2 square. We have to take the highest power, so 2 square. Next prime number we have 3. So we doesn't have 3, so we will write 3. We have 5 and we have 7. So 2 square 4. 4 into 5. 4. Okay. 4 into 3 into 5 into 7. Multiply this of 20. 21. So 21 into 2, that is 4, 2. This 0 will come. So 420. So in the library, if there is means 420 books, then everyone will get the equal numbers of books. So hence the required number of books, hence the required number of books, hence the required number of books is 420. So now come to the question, example 17. Also show that, example number 17. What does the example number says that? Show that any numbers of the form 4 to the power n belongs to natural number, can never end with the digit 0. What does this number say? If we take the power of 4, means 4 to the power 1, 4 to the power 2, 4 to the power 3, will we get at the end 0? That is the question. So we will never get the we will never get the 0 at the end. If you multiply the 4 with 4 times, 3 times, 5 times also, will never get. Why will never get? Because this number is not divisible by 5. Whenever we will get this 0 at the end, whenever any number is divisible by 2 as well as divisible by 5, then only we will get the 0 at the end. Example 10 is divisible by 2 as well as 5. 20 is also divisible by 2 as well as divisible by 5. So at the end we will get the 0 only if the number is divisible by both 2 as well as 5, because in the 4 we will never get, because this number is not, this number is not divisible by 5 as well as not divisible by It is divisible by 2, but it's not divisible by 5. And if the number is divisible by 2 as well as 5, then only we will get 0 at the end. So now we have to write it down. 17th. So any number, if any number end with, if any number end with the digit 0, it should be divisible by 2 and 5. Here we have the 4 to the power n. So 4 to the power n, there is 2 into 2 n. So we can write 2 square n. So it is 2 to the power n. We have only the here 2 is the only factor. So 2, this is 2. Here we have only 2. So 2 is only factor of 4 to the power n. So 5 is not, we doesn't have 5 here. 5 is not factor of 4 to the power n. Hence 4 to the power n can never end with 0. So can never end with 0. Come to the question number 18, example 18. So this is the last example of this. Show that 12 to the power n can never end with the digit 0 or 5 for any numbers, for any natural number. Here same means if we multiply 12, if we take the power of 12, that is 12 to the power 1, 12 to the power 2, 12 to the power 3, we will never get the 0, and as well as we will never get the 0 and the 5 at the end. So it's exactly same as before. That is the question number like example 17. Here only the number is different. This is 18. If any number end with the digit 0 or 5, it should be divisible by 2 and 5. It should be divisible by 2 and 5. So you have here 12 to the power n. So 12 n. Prime factorization of 12, that is 2, 6, 2, 3. So 2 to the power 2 into 3 n. So this is 2 to the power 2n into 3n. We have 2 and 3, we doesn't get the 5. So 2 and 3 are the factor of 2 and 3 are the factor of 12 to the power n. So 5 is not factor of 12 to the power n. So hence 12 to the power nth, 12 to the power nth cannot end with 5 or 0.